Hi, I'm Jeremy, and we're going to be talking about DevOps and software delivery in a global pandemic and what we can learn about better DevOps practices. So before I get too far into this, I want to call out the immensely important State of DevOps reports. These are highly valuable and have helped to drive the important practices and behavior shifts in the industry that we've seen over the years. The big difference between our report that we're creating each year now and these other reports is that the industry reports are largely based on survey data and based on and potentially biased by the memory of the engineers who are taking the survey who chose to participate. Often when taking surveys, we kind of fall into the trap that John Allspaw once tweeted a few years back of work as imagined versus work as done, or as we're calling it, performance described versus performance derived. Given that our platform is used to perform many of the activities associated with high performance teams, it allows us to kind of measure the actual behaviors being performed to get a better understanding of how actual engineering work gets pushed through the pipeline. Like, did they actually push the code as often as they claim they did today? And how long are their workflows actually taking? So, as I said, my name is Jeremy Meiss. And I'm the director of DevRel and community at CircleCI. We're a continuous integration and continuous delivery company. You can follow me on the Twitters at I am Jerdog. So at CircleCI, we have this massive amounts of unique data on how technology delivery teams behave in the wild. This report examines over 55 million data points from more than 44,000 organizations and 160,000 projects. Which makes it, pretty much larger than any other survey by far. We started looking at all this data in 2019, figuring out how we could kind of slice and dice it up. And then in this last year, with the whole world kind of changing, we really wanted to see what had changed in the data with how developers were working. We don't believe in this one size fits all success metrics for delivery. Every team is different. And so, however, the software delivery patterns we've observed on our platform, especially the data points from top delivery teams, show some key similarities that suggest valuable benchmarks for teams to use as goals. So one of the big things that we offer was kind of a set of baselines for the 4 metrics related to CI that we think are most important for developer teams to track as far as measuring velocity and engineering efficiency on their teams. These would differ slightly from the 4 classic metrics of deployment frequency that we kind of see here. So deployment frequency, lead time to change, change failure rate, recovery from failure time. So those are kind of the traditional classic metrics. But for us, we kind of identified these benchmarks for high performing continuous integration, continuous delivery benchmarks for high performance. Yeah. So those would be duration, which, less than 10 minutes, throughput, being, at will as often as you can, mean time to recovery, being, less than an hour, and success rate being, more than 90%. So let's go ahead and jump right into the data. Throughput. So originally we thought about this as, how often are you committing? How often are you, pushing your code? But then we realized that commits can sometimes be grouped and pushed into, continuous integration systems at once and not always running all at the same time. We see that most projects are set to basically run their CI per push to the Git server. And so some do it on a schedule, but most usually push it to the Git server. So looking at the data between 2020 and 2019, at the 50th percentile, people are triggering CI about 0.7 times per day, which isn't a lot and is a slight dip from 2019. But at this 95th percentile, you're getting a lot of increased activity at roughly 32 times a day. The mean, though, kind of shows that projects are primarily sitting at 8 times per day versus just under 6 per day in 2019. What we found here is that most projects just aren't really deploying dozens of times per day. They're not even validating their software dozens of times a day. And so while it's not untrue that a description of a high-performing team is one that deploys a lot of projects, it just means that it may be one project that's moving that fast, but a whole bunch of other projects that they have really aren't moving as quickly. Looking at the total sample of everything going on within an engineering department versus maybe just their primary thing kind of helps us to see this. So duration. What we see in the 2020 data is that 5% of builds finished in less than 12 seconds, which when you think about 5%, that doesn't sound like very much, but we're looking at like 500,000 builds in that sample. And that's not a small number, which then kind of begs that question of like, what can you get done in 12 seconds? And the answer is probably not a lot, but some people can do quite a bit in that 12 seconds. If you have many unit tests that can be parallelized, or maybe you can run a whole unit test suite in that time, or if you're uploading an artifact into an S3 bucket to get it ready for deployment, you can probably do that in less than 12 seconds. For 2020, the 50th percentile pegs at about around the 4-minute mark. And as a developer, if you're getting good quality feedback in 4 minutes, that can be a game changer for sure. Now, the 95th percentile is sitting at 34 minutes. And for a lot of companies, depending on what's being built, what your test scenarios are, and how thorough all of that is, that 34-minute mark is a good place to be. But what we're seeing is that half of all builds are still finishing in about 4 minutes. Comparing that to 2019, we're not seeing a lot of movement there, with the durations going up just a tiny bit, usually indicating a bit more testing is happening as we've seen on the platform. So success rate. As we look at success rate, we're looking at how often does your pipeline complete with a green status. A pipeline can complete with either red, green, or error. And error here just means incomplete. Something couldn't be done. It could be that an external resource was not reachable, or you were putting an impossible scenario in place, like a test divided by 0, and you blew up the whole thing. I know this by experience. We're going to move on. But for us, for a success rates at the 50th percentile, we're seeing 61% of all pipelines are passing in green. When you look at the lower and higher end of those numbers become less meaningful because there's a group of things that never fail, and there's a group that always fail. So when you throw those out and just look at the middle, you see that roughly half of all builds are passing. What this tells us is that a lot of people are just testing out projects, dabbling with CI. How many of us have started up a project over the weekend, started messing around with building it, and then haven't gone back to that project? Luckily, we're virtual and we can't all see everyone's hands raised. I know I have. Heck, I have over 20 domains sitting there in Namecheap doing nothing. We really didn't see much difference here between 2019 and 2020. So mean time to recovery, the recovery time. So in the 5th percentile, we see 2 minutes that it'll sit in a failure state before it's recovered, which is just under a minute improvement from 2019. A lot of times in those scenarios, that could be from multiple contributions running in parallel, where developer 1 pushes bad commit and developer 2 pushes a good commit. The bad commit fails really quickly, with the good commit succeeding right afterwards, or it could be the same developer. I know I've pushed something and I realized quickly what I broke, and I pushed that fix immediately. And we're not even going to go down the rabbit hole of all my commit messages that show that. So at the 50th percentile, you're seeing about an hour until it's recovered properly, an improvement of 3 minutes. And then from there, you start seeing things that are probably more attributed to some code gets pushed, and then you go home and you come back the next day to check it. The mean here at 14.85 hours really kind of illustrates that. It's about the time of the end of a workday to the start of the next. It's the 90th and 95th percentile where it looks like people just kind of go home after they've started the build. We're seeing improvements for the most part, but this going home bit is interesting because it tends to kind of butt up against the classic continuous delivery philosophy that says, like, you can't go home if the build's red. But there's also some pragmatism here that, like, we go about when where you're analyzing the build. Is it really the most important? Maybe it's a test build. Is it a feature branch? And we're not going to judge on someone's work habits on going home to come back the next day and check on the build. So overall in 2020, we've seen recovery time definitely decreased, and it's moving in the right direction. We can hypothesize here on this a little bit, and Instead, it's because more people are home and more attentive to what's going on with the code, and there's maybe less stepping away from the office for a cup of coffee or that sort of thing. All right, so what I kind of move into now is kind of looking at the insight we've been able to gather from the last 2 years of reviewing this data and what we can derive from it. In case you didn't know, 2020 has been a year, and it's been a year like no other. We're now, almost a third of the way through 2021, and even looking back, like it's just the last over a year has been crazy, been just wild. We can't look at the data we've seen so far without thinking about the impact of a global pandemic on DevOps and software delivery. How has it affected team performance? And that was what really drove us to dive even deeper into this data with that lens. So with throughput, we have the data from March to May of 2019 on the left, March to May of 2020 in the middle, and then on the right is our August 2020 data. And that's going to be the same for all these graphs going forward here. For many of the percentiles, we saw a slight dip as the pandemic was hitting, and then the maximum was reached in April of 2020. Now, I think this makes sense in the face of global uncertainty, and I feel it's it's wise to take our engineering teams and shore up business interests. And in this case, it seems to reflect that teams began automating as much as possible with the entire workforce heading home and companies doing that very thing, shoring up. So there's a lot of that shoring up of core applications as quickly as possible, resolving bug tickets, issues, et cetera, in order to really lean on the stability of the platform or make it stable in some cases. And if you think about what was happening in April of 2020, that was primarily lockdown mode in North America and a lot of Europe, and we saw a whole lot more code going into the system. We also saw a lot more activity happening on the weekends than had previously been happening, along with more hours in a day where CI activities were kind of taking place per project, roughly 14 hours where it had been 11 or 12 previously, which can be reflected in no more commuting times. You're not sitting on a train or in a car traffic on your way home. You're just able to stay at home and finish what you're doing. So with duration, we see the mean falls heading into this pandemic and then stays steady. But the 50th percentile and above, the duration increases year over year with a slight dip in April and then increased again in August towards the longest duration year over year. So kind of what we're thinking here and as we're seeing is that that's indicative of you're shoring up your business in this type of environment, and you're adding more tests to your test suite, to your CI suite, and more fine tuning of your code in your testing. And then in that testing, you're increasing your parallelization or optimizing right away to make sure that the application is as stable as possible. This also holds true as we see throughput also grew around this same time. Success rate. So with success rate in the pandemic, when we look at the 50th percentile, there are some things that are always green and some things that are always red. What we see with this uptake in success rate for 50th and 60th percentile is about the same year over year, though. This tends to show your typical red to green type of cycle as people are kind of testing out new features, innovating, etc. No one expects every single commit to be perfect every single time. So a healthy, innovative engineering team tends to have somewhat a high degree of failure, and that's okay. But when we see things like a peak, kind of hear about the same time kicking into the pandemic, that signals that with the average engineering team, they're likely doing less innovation and more shoring up of the core business, like resolving those tickets and issues, bugs, etc. And when you're resolving bugs, you're going from red to green, you're getting more stability in the system. So we would expect to see a peak in success rate. Then once the business is stable again, the success rate would go back down and you'd see more innovation or new feature branch development happening. Now, the lower bar here, that the red kind of trailing off towards the end of last year, signals to us through the data that people are starting to test out more on automation tools, testing out CI tools, and starting with a handful of commits where they're not likely to be very successful. And we've seen, kind of the other thing here that's interesting about success rate is that success is the state you want to reach. And there are many ways to get to a failed build, but really one way to succeed. So if you have something that's failing, you could push another commit, it could fail again, and you push another, et cetera, doing that a few more times until you've pushed 5 commits, which all failed. And then the 6th one was the success. So now you're at, a 1 in 6 success rate, which we can see trailing off, here at the bottom on the graph. Success rate can be an interesting statistic that can tell you a lot about how your teams are functioning, but isn't always indicative of bad process or performance. So the kind of hypothesis here that we're kind of working with is that success rates were basically the highest on record throughout April and May. And one thought here around that is that the level of distraction for many developers, like not getting to conferences, no traveling, et cetera, was removed, and they started working on all the software and core business and shoring that up. Recovery time. What we've seen with recovery time in this data, and follows the same basic path from these other metrics, is that they're declining. In the 95th percentile, we're seeing that year-over-year drop, but a big drop in April and May. And those are generally reflective of that if stability is the business's goal, especially with those commits that you're pushing during this time. With what we saw in the early stage of the pandemic was an all hands on deck mentality and getting to resolve issues as quickly as possible, getting their signal back as quickly as possible, mitigating issues, and so on. And that's that feedback cycle at the heart of CI and rapid app development. Everyone wants to see a decrease in recovery time, but you see signals like we have in this plot here that come from the ability to bring everyone together and focus back on the core business and shore things up with the uncertainty of early COVID times. So the hypothesis here is, would tend to really show that we had more developers pushing code, fixing issues, and they had less distractions like conferences, travel, et cetera. Everyone's back on trying to get to the stability state that's important to the business. I do, though, want to stress that just because you're at home and not having distractions from your coworkers, that doesn't mean there aren't distractions at home. And I think that's an important distinction here. There are plenty of distractions at home, and it's important to take that time for yourself. But what the data is shown is that some people were able to do more while at home, others were able to do less. All right, so kind of the fun little spot now is kind of looking at the things that kind of make you go, So, with branch info, we're in an interesting position to be able to see how people are actually using their branches in development. During the pandemic, especially June through July of last year, and even continuing now, as the social unrest and Black Lives Matter protests rightfully exploded onto center stage and need to stay there. And part of that was a resurgence of an older discussion about, in the tech world, about the term master and slave throughout tech industry and the important quest to find better language that's more inclusive. So we took the data and we kind of asked our data scientists to see what they could find if the use of master as a branch name decreased year over year. We, of course, saw a lot of press around this and online petitions and discussions on Twitter and companies committing to doing so. And GitHub, came and published how they were going to change the default branch to main instead of master. And so I can say that realistically, we've seen almost no real decline in the use of master as a branch name yet. Now, while I think this is sad that the data hasn't really reflected it, I think we're seeing more and more tooling default to better naming conventions. So I believe that we'll see more of this in the near future. In some companies, especially with a lot of technical debt and large, repositories and whatnot, it's hard to just make such a big change. But we are seeing that start to change, and I think that's important. Success rate. Another thing we noticed was that, there was a difference in success rate between branches, with the default branch being higher than on non-default or feature branches. We saw that the success rate is 80% on default branches at the 50th percentile and 100% for the 75th percentile and above. What this is telling us is that a lot of the innovation is happening on feature branches, with 58% success rate for non-default branches at the 50th percentile. Once things were, more successful, then those they were moved to the default branches, and the success rate went up. Duration on the default. We saw that the duration on default branches was faster at every percentile over non-default branches. So this tells us that the mainline branch people work on test engineering, working on making it fast, making sure that the feedback is good, and continuing to iterate. recovery time was lower on the default branches at every single percentile, meaning that people who are relying on mainline, they're watching the recovery time a whole lot more to make sure that fewer people are impacted by a red build. All right, so final little bit here is kind of looking at what are some of the development practices that we saw that really what we would say definitively work. Success rate does not correlate with company size. So when you look at organizations and how many contributors are in that organization, if you have 800 contributors in your GitHub org, or you have 4, we can't really tell that just by looking at success rate. It doesn't matter how, it's not a one-to-one thing that, larger the company, the more success rate. Duration. Another thing we've seen is that duration is longest for teams of 1, which I think makes sense because if you're a team of 1, you really aren't a team. But secondly, you might not care if it takes you a long time to get feedback because there's no one else waiting on you. And I think there's a kind of a social construct here that when you know that you're in the way of somebody else, you will do extra work to make sure that it's faster or better understood or better take care of it in a better way. And those are some of the things that we miss when it's just you. So recovery time decreases with the increased size of your team, which we found played out up to about 200. Above that, the data is a bit fuzzy since we don't see a lot of data with large teams over 200 all at once in that same repo. They might be spread out across all the different repos in an organization. So basically, the more people you're impacting with a red build, probably the faster you are to recover it. When things are red, you're holding up a lot of other devs in their work. You get Slack messages wondering why it's still in red. So the incentive is to get things resolved and back to a green build quickly. Performance is better with more than one contributor. I feel like that's something that we should make sense in that it is every outcome we could measure showed that you're better with you, and if you have more people you're working with on X thing, you're going to be performance is going to be better. And kind of the takeaway here around software is collaborative is that software really is. This isn't new, but we don't talk about it enough, I don't think. When we talk about data and metrics, this is a thing that we're able to kind of really prove out in our data here, is that when you look at the outcomes and success rates of teams, team sizes and number of contributors that you have, you can see that putting more people working on a project is going to give you better outcomes. Seems to kind of follow. The last one here is don't deploy on Friday is not a thing. We see, on Twitter every once in a while, you see the whole don't deploy on Friday, and the trend goes up, people start talking about it, and then it fades away. We kind of looked at the data because we had the massive data set, and we noticed that 70% less throughput on weekends, and there was 11% less throughput on Friday, and we looked at this from a UTC perspective, and then 9% less throughput on Monday, also UTC. So we could kind of standardize the time and look at it over a 24-hour period. What this showed was that people are still deploying. Yeah, maybe it's a little less on Friday, but primarily don't deploy on Friday is not a thing. And I'm sure that will spark some controversy, and I'm here for it. All right, so the last thing here, if you want to see the full report, which really dives a lot deeper, it's probably more interesting reading it than hearing me talk about it. You can find it, scan this QR code. The slides will be available. And then you can go to circles.ci/SSD 2020, which is State of Software Delivery 2020. And you can get the full report there. You don't have to sign up for anything. You can just get the free full report. And thank you. I appreciate you coming to the talk.